Today I'm going to show you one of the functions, including in your essential license, import data doctor. In short, right, we call it IDD. So what can IDD help you? So this training session, trying to show you how to use IDD repair tools to close up a gap between a surface you created and in the imported model. Show you some trick, how to use the correct geometry, right, to combine everything into one environment. And the most important is the correct way of working flow in IDD mode. Then show you one of the function, a very powerful function in IDD mode. We call it repair tools, right? Repair tools. I will go into the Creo now. I'm using Creo 9.0. So as I say, right, in your essential license, IDD is come together. So you don't have to buy additional module for IDD. So usually, right, when we receive a step file or IGS file or any third-party software, right, for example, SolidWorks, CATIA, Inventor, right, any different format of file format that you receive and you want to open in Creo environment. For example, now I'm using a step file. So I just import the step file into Creo environment. So this is the way how you import, right? So for those who import before, this is nothing much new to you, no challenge at all. If you want to use your own template, you can always check the template. I will always advise you to use the template. So what does that mean, template, right? So when you go in detail, you can see for example, for part, my template setting is go to look for units template. Right, for assembly, right, you look for also as well for my case. So if you do not have if you do not set a correct config.pro option, the default it is looking for inch, right, inch template. So for those who are interested to know how to set this, right, then can write down in the chat later on. I answer, because this is quite a basic stuff. I think many of the users you should know how to set it as a default. Of course, you can use option to toggle, right, to browse to your template, right, to browse to the right template. For example, browse to the solid part template. Okay, so this is about the detail. So once you use the template and then you say okay, so your step file in this case for this example will be imported as a part, because the step file for this example is a part file. It is a part file. So now I'm retrieving this step file into Creo as a part file, and this is Creo 9.0. The way how you work in IDD mode for other version, for example, Creo 4, Creo 5, or even Creo 2 or 3, right? The method is about the same. The method is about the same. So when after you successfully open or import your step file into the Creo model, what is the first thing you should look at? The first thing you should look at is the color. When you toggle to wireframe, look at the color. If this is a color that you see, so most likely this is not a solid. If it's a solid, right, usually the default color is about a bit gray, a bit gray. If you toggle to to shading mode, if you see the color like this, a bit bluish, this is also not a solid. This is also a surface. So this is the first method, how to evaluate your model. Is it a solid or is it a surface? The second method is you can go to analysis, go to mesh property, go to preview, all right? Then take a look at the result. If you see the volume is zero volume, meaning that confirm this model is fully surface, no solid at all. Now, if you can see some value for the volume, meaning that this part, right, it might have some solid. Maybe it's a combination of solid and surface. So this is the second method, how you evaluate this part, whether it's a surface or it's a solid. Then the third method in Creo 9, right, you can go to the model tree, here. As you can see this information in Creo 9. So now I can see one body number 1, and look at the icon. The icon is transparent. When the icon is transparent, meaning that this body is not a solid. So this is also one way how you interpret this model, or how you evaluate whether it's a surface or it's a solid. So three methods already, by color, by analysis, mass property, by model tree, icon. The method number 4, right? You can use this binoculars over here, the search tool. All right, fine. So what you can do, right? You set the setting to age, set the look for age, set the attribute to type, look by type, and then set the comparison to is equal to, set the value, change from two-sided to one-sided. So if you, right, by doing this type of setting, you find out, you will notice that you got if you found something, right, meaning that these are all the gaps. This is all considered the gaps. You can right click, you can select all the item found and then bring into the right hand side. When you close it, right, all the gap will be highlighted in green, like so. So these are all considered gaps, right? Surface got gaps. When surface has gaps, so this model cannot toggle into solid. So this is how the way this is a setting, how you use the search tool by setting the age, attribute set to type, comparison is equal to one-sided. Then you find out if you see something like this, meaning that this surface got a gap. All right, then the next thing we need to do, right, is using IDD to fix it. So for those who are interested on this, right, you can take a photo now. Give you 5 seconds, take a photo. So next time you can use it to find gap. 1, 2, 3, 4, 5. Okay, done. So once you know roughly where are the gaps, right? The next thing is we are going into the imported feature. So this is the next next topic in IDD. So the first topic is evaluate your model. So I already shared with you 4 methods how to evaluate your model, whether it's a surface or it's a solid. After you know this is a surface and you know where are the gaps, where are the problem, then the next thing to do is we are going into the IDD mode. Now, how to go into IDD mode? We go to the import feature, import feature over here, and then we do a edit definition. Inside the definition, import definition tab, we go into import data doctor. So this is the command where you go into IDD mode, right? So once I click this, I'm inside import data doctor tab. So the import definition tab is here, IDD is here. Okay. Now, when you are in the IDD mode, right? What you should look at, the first thing you should look at the model tree. You should try to understand what are all these items for. For example, when I click on the first item here, I notice that most of the surfaces are highlighted. So meaning that this is the main body here. This is the main item. These are the main surface. All these surfaces are grouped into this quill. How about the second surface? This second surface, right? It is highlighted here. Now you can also right click here and then do an isolate. So once you isolate the selected surface, the selected surface will be isolated like so, so that you can quickly find out where is this surface, right? So this surface is somewhere around here. So this is the way how you evaluate the surface. Now, after you know where is the surface, right? I would suggest you to unhide the main surface, zoom in to the surface that you are evaluate right now, and then do a hide of this surface. Right, once you hide this selected surface, you notice that you can see through. You can see the inside. So meaning what? Meaning that this surface, right, is a required surface. It's a surface that needed. All right, it's a needed surface. So it just because the surface is outside and hide, so the surface is now come outside. So what you should do? Drag this surface before the major quill, expand the quill, then drag this and drop into the same family or same group. So now this surface, right, has been added into the same group. When you toggle to wireframe, as you can see, the color they are all changed to the same color, meaning that they already merged. Now, let me undo one step. So the surface was outside, right? The surface was outside. Then look at the color. Look at the color. The boundary color is a bit orange, a bit pink. Sorry, it's a bit pink. So this means what? This means that this is a gap. You can use find gap. You can use this the search tool to find gap. Take a look. See, this is considered a gap. This is considered a gap. So this color. So when I bring this surface drop into the family, the big family, the color automatically turn into blue, and this equal to it's already been zipped automatically. So this is now no more gap. You can find gap, or you can search again. See, now left 40 gap. So you bring to right. Now this is not considered a gap anymore. So meaning that this area, right, has been fixed successfully, right? This area. So if we do the same thing, we continue on the other surface. So we do a view default. Then this surface, right? The second surface, I do an isolate this surface. Then this surface is located somewhere on top of this tire, right? Zoom in somewhere around here. So I want to know whether this surface, is it a wanted surface or this is not a wanted surface. So what I can do, right? Sorry, I will unhide the major group. Then this is a surface. I will hide this surface, Once I hide this surface, I realize that there are still another piece here, no? So meaning that what? Meaning that the big group, right? The big group has already has this surface. So this surface, right, become what? This surface become a redundant. It's a overlapping, become redundant. Because of this surface, right? So the whole thing, this become a gap. But this surface is a redundant surface. So this surface, we suppose can delete it. So what we should do, select this surface, then we do a delete. All right, once we delete this surface, look at the color here, all become blue again, meaning that the original surface, right, in fact, is already merged. Then followed by the last piece, do an isolate, somewhere around here, very small piece here, very small piece. So spin the model, take a look, somewhere around here. All right, so we repeat the step, unhide the major, the small surface, we hide it. After you hide, right, then you spin, you can see can you see this line? So after you hide this surface, right, you can see the surface behind. It means what? It means that this unhide this surface, right? So this surface, right, this surface is a wanted surface, right? This surface is wanted, It's just because of this surface is outside the big family. That's why you see the color of the boundary, it is pink. So meaning that this surface is not hide, it's not merged yet. So what we should do, we should bring this surface, go up here. Okay. Now before I drop this surface into the family, right? You should focus on the color. You should focus on this color. See, look at this color. All right, this color. So when I bring this surface drop into the big family, usually, right? Usually it will automatically merge for you. See, it automatically merge the surface for you. Okay, so up to this stage, right? I left only one group, one major group. Then I do find gap, right? I try to find gap. See, I still got 24 gaps here. So where are all the gaps here? All the gaps here are here, located at all this area, all this area. All this area. So you can toggle to wireframe. All right, look at the green color edge. Look at the color, so you know, right? These are not merged yet. So I repeat, once you go into the IDD mode, the first thing to do is study the model tree and try to understand all the surface, individual surface one by one, and then you just delete accordingly, or drag and drop into the group accordingly. After done all this step, the next step we should do is we do a repair. Okay, you can quickly do a repair. Repair is something like auto zip, auto zip. So once you repair, you say okay. Notice that all the gap that can be zipped automatically, it will zip for you. So now we find gap again. Now left only 2 gaps. See, it was about I think 40 or 24, about 24, the last one. So now left only 2 gaps. Okay, so finally, right, I left this gap, and the rest all zip, auto zip by this repair. So finally, right, this gap still cannot be zipped. So I'm going to study this one and see what's wrong. What's wrong with this surface? Why still cannot auto zip? So first we select the surface here, and then we select this surface as well, and then we study. Right, got to zoom in and then study. Can see the surface haywire. I think, right, I think this surface go haywire. You agree? All right, see? All this surface go haywire, go outside. And then when I spin here, right, this surface go inside. So the boundary, right, this boundary go haywire. But how about this surface? This surface, right, seems like okay, you know. If you compare this surface and the neighbor surface, right, these two surfaces, right, seems like no problem. Huh? So the problem comes from this surface. So once you understand where is the problem come from, what you should do, right? So you know the problem is because of this edge, right? This edge is a problem. So what you should do, select the problem edge, then we use a replace command. All right, replace command is under import data doctor. So select the problems edge, and then we do a replace. All right, under replace, right, you select the good edge. This is the good edge. Good edge. After you select the good edge, then you okay. Once you okay, the problem edge, right, will be replaced with the good edge, and it automatically zip for you. So now we do a find gap again. We do a find gap again, and we notice that 0 gap. All right, find now no more gap. So meaning that all the gap has been successfully zipped. So once this step achieved, what we can do right now is we hit OK. We exit from the import data doctor. No more gap, all right? So we say OK. We come out from the import data doctor, and we add geometry. Right, either add geometry or add boundary. In this case, right, it's the same because only one body. So we say add geometry. Add geometry meaning that becomes solid. Becomes solid. Then we hit OK, and look at the color change. OK. Now the color change to a bit gray, like so. So this is solid. To confirm, we check the body icon. Now the body icon become solid. We can also check the analysis, mesh property, and then we do a quick, sorry, we select the body, select this body, and then we coordinate system, all right, assign a coordinate system, assign material accordingly, assign material density, right? So we can assign a density according to, you can put a dummy density 0.1 or 0.0, doesn't matter. I just want to know whether is it a solid or not a solid. So once you have assigned the density, the density, right? You can see the result with volume. See, volume. When you see some volume, meaning that this is already a solid. This file has been solid. Of course, you can also find gap again to confirm no more gap. So this is the way from start, import, evaluate the problem, go into the IDD, study the surface, delete away the unwanted, combine together with the wanted, and then we do a auto repair, and then we may do some replace action. Then we add model, finally add geometry. Finally, we add geometry, and we come out from the import data doctor, and everything will be now in solid. Okay, so this is the first step or first lesson that I bring it to you. So I'm going to show you the second example. I got many examples, in fact. So I really do not know how compact is your model. So the second example, I import it as usual, use template, then okay, accept whatever name. That is not important. So once the thing is ready, so repeat all the steps, right? First, what is the step? Look at the color, right? Look at the color. Second, look at the icon. See, the icon is transparent. So this is a non-solid. A third, go to analysis. We do a quick mesh property analysis. Volume, 0, right? 0 volume. So this is not a solid. This is a surface. Then finally, right, I do a find gap, right? Find gap. And I realize that I got 18 gaps for this example. So I bring it to the right hand side and highlight all the gaps for me, right? So these are the problematic area. These are the problematic area. Okay, there are some small gap over here and here for this example. Okay, after I roughly understood or understand where are the gaps or what's the next step, I will do the edit definition for the import feature. Then from the import definition, I go into import data doctor. When I in the IDD, the first thing I should look at is the model tree. So for this example, I got one quill over here, the majority. I got second, another quill over here. I don't know where is it. So I do isolate this. Oh, it's here. All right. So this is the majority. So it's hide behind, it's behind, somewhere around here. So I want to know whether this surface is it wanted or unwanted. So what should I do? I will unhide the majority. Then this is the minority. When I click on it, right, I can see overlapping. Okay, I think roughly I know this is redundant. So let me confirm. Let me hide this surface, hide this minority. Then I can see there are still a surface here. No, so meaning that this surface, right, is unwanted. Right, this surface can be deleted. Can be deleted. This is a redundant. So this surface I can right click and do a delete. Okay, so this is the first thing I should study like this way. Then what is this surface? Isolated. Isolate this surface. And then where is this surface located? View default. Somewhere around here. It's one of the gear surface here. It's one of the gear surface here. So zoom in here. So now unhide the major. Then this is the problem surface. As you can see, right, the surface is a bit bigger. The surface is a bit bigger than the boundary, the small edge here. Okay, for this case, right, what you should do? Bring this surface up, expand the quill, bring this surface inside the quill to make them one family. All right, so when you click on this quill, right, they are all in one family, but they are, this is still considered gaps. This one not merged yet, not merged yet. So for in this case, right, this surface, right, is bigger than the actual hole. So for this example, what I can try to move vertex. Right, use another command. So just now, right, I show you the command replace. It is under here. So this is a column for you to edit. So replace is one of the function. Another function or another command is called move vertex. So for this example, right, I can try move vertex. I can try to move this vertex from here to here. Make it close and then drop. All right, it will automatically snap from this tab and then move here and then drop here. You should automatically snap. Once it snap, right, look at this color. This edge, right, already merged. Okay, so seems like can use so go to this point, drag, and then go near this one and then drop. Look at this edge color change. And finally, I drag here and then drop here, snap here. So look at the color, all merge nicely. So to confirm, I do a find gap. So I can now do a find gap. zero gap. All right, fine, zero gap. So no more gap. It's all fully merged successfully. So I'm using merge, I'm using move vertex for this example. Instead of using replace, I use move vertex. So when I say okay, as usual, I go add geometry. Then I say okay. Now look at the color, shade it, solid. So this is a second example how to use move vertex in the import data doctor environment. I will continue with my third example. So this is also a step file. As usual, use template. As usual, look at the model tree, look at the icon, transparent, look at the analysis, mesh property, and then look at the find gap, 8 gap found, right? And bring to the right hand side and look at the highlight. So you know roughly where are the gaps, right? Roughly where are the gaps. In this case, right? Oh, this one is horrible, huh? Because this surface, right? I mean the gap, right? I think it's referred to this surface. So it's a missing surface, no? It's a missing surface. It's a missing surface example. Right? Missing surface, huh? It's a missing surface. So the rest, right? I think it's all okay, but missing surface. So since it's a missing surface, right? It's no point for me to go into IDD. In this case, right? What should I do? Right? So see, 1 surface, 2 surface, 3 surface, 4 surface. All the surfaces I highlighted here is surface outside. Then you can see the surface inside. You can see the surface behind. So this is a missing surface. So missing surface, no point go into IDD because in IDD, right, you can't do anything. So for this case, right, what should I do? I should create an additional surface using boundary blend. I think it's good enough because I got 4 boundary. Because I got one edge, 2, 3, and 4. I can find 4 edge. So since I can find 4 edges, so I can use boundary blend to create the surface. So in this example, I'm going to using this and create the surface, the first direction from here to here, and the second direction from here to here. Right. So I try this first. For those who know how to use surface, right? If you do not know how to use surface, then sorry, you got to either learn it or attend the training. For those who know how to use surface, so you just simply create the surface using whatever method that you know. For this example, I'm using a boundary blend method. So for this, right, it's a tangency. You can right click and then say tangent. I use all this Creo command to make the boundary condition to be tangent in this case, tangent to the boundary surface, right? Tangent. So all 4 tangent. Is it done? So the surface created. The surface is outside. The surface is outside. When you toggle to wireframe, you notice that this is considered a gap. It's still considered a gap because this is not merged yet. Right? It's not merged yet. I still got one more piece is here. One more piece. So this is also a gap. This is also a gap. So what should I do? Same thing, go boundary blend. In this case, the first boundary, second boundary, and the second direction, second boundary. Right? Same thing, if you want to toggle to tangent condition, then you just toggle accordingly. Toggle accordingly. Sometimes if you toggle, it fail, right? Meaning that this curve is no tangent condition, right? Cannot toggle to tangent. For this case, right, seems it's okay. I'm able to toggle to tangent. So this surface has been created like so. But it's not merged yet, right? It's not merged yet. So if you find gap, right? If you find gap, you still can see many gaps. All the gaps are focused in this 2 area. Okay, what is next? Next, if you look at the model tree, you can see, right? This is an imported feature, the original imported. You created 2 surface here, right? 1 and 2. So the next thing to do is the next thing to do is select all the surface and then do a merge. So you merge them together, become one quill. Fail to regen. All right, if fail to regen, right, then no, then we got to do one by one. For example, select this one and then select the whole surface and then merge and try. Right? Successfully, yeah, one by one successfully. So now this is one piece control with this the another quill. Then we do the second merge and say done. Yes, see, merge, merge. So to confirm again, I do a find gap. So 0 gap. So meaning that up to here, I got two merge. I got two merge here. And finally, the gap, the quill is all successfully merged together into one piece. So next, I will select the whole quill. I will highlight first, select the whole entire quill, right, and do a solidify. So now I'm using another method, solidify method, to solidify the closed quill in this example. So now look at the color. This is solid. Okay, so I'm do not, for this example, I did not use any IDD. I'm using another method, external surface created method, and then we merge all together, become one closed quill, then we do a solidify. Now, eventually, right, if you want to combine all these features into one, you can do a collapse. You can select all this from the import to the last solidify and then do a collapse. Right? If it can be collapsed, right? You say highlight feature cannot be collapsed, right? Then no try, cannot collapse. We can try one by one. Maybe we can collapse these three first. Collapse is for you to combine, to break the parent and child relationship, like so. Right? So now I combine these three again. The second time collapse. All right, now no more history. All the surface that I collected, no more history, no more parametric. Finally, right, I collect the imported and the incremental geometry. Collect the third time. I still cannot collect, right? Doesn't matter. I just leave it until here. So this is a step that how you should handle the problematic imported surface with a gap. And the last example I'm going to show you is a part that already been imported into already open in the part mode. And when I do a color check, when I do the body check, I notice that no solid, a lot of surface, a lot of quill. When I do a find gap, I notice that 0 gap, all are solid. Oh, no, sorry, no gap, but it's no solid. So I will suspect. I go into the import feature. I go to import data doctor. I notice that there are many body. There are many body. Oh, this is so-called the multi-body example. Okay, so there are many body. So if you click on the body, the body will highlighted one by one. So what you can do, right? You can isolate one body and then do a study. All right, this is considered one body, right? One body, another body, isolate another body. Right? This is another body, etc., etc. Okay, so I will do a yes. All right. So in this case, right, all no gap. For this example, all the body are nicely zipped, no gap, but it is still surface. So to convert this type of example into the solid, you can try add body. Creo 9. Creo 9 allow you to convert all the quill, individual quill, into the individual body. So before I hit OK, I hit add body, and I want you to notice, I want you to take a look of the body. Now I got only one body, and I got 9 quill, 9 items, basically, 9 group, 9 major group. So once I say OK, here, with this add body, it automatically convert all your quill. See, no more quill, no more quill. But now you got 10 body. In fact, the body number 1, right, is a dummy. This one we can delete later on. Right? What I want is this one, the imported body. I got 9 imported body. So if you expand this, you can see all the body are converted correctly. So you can select accordingly, or you want to isolate accordingly also can. Right? This is one body, and this is solid. Okay. So reset status, come back. So of course, if you want to do for this example, right, I can also try cross section to confirm that this is a solid. So I do a cross section. And cross section will tell me, right, this is a solid. See, it tell me they are all solid now. So this is a multi-body example. Again, if you use the find gap, you see 0 gap. All right, and this is not assembly. This is a part with multi-body part. Only Creo 7 and above can do multi-body, for example. All right, for your note to take note. Creo 6 and below all cannot handle multi-body. You got to use assembly to achieve this.